Let us start chapter 11, Force and Pressure. In this we will learn force is a push or a pull. Forces are due to an interaction and directions of forces. So in our everyday experiences, what do you do to make a football move? What do you do to make a moving ball move faster? How does a goalkeeper stop a ball? A hockey player changes the direction of the moving ball with a flick of the stick. Flick means a sudden quick movement. How do fielders stop a ball hit by a batsman? Actually, in all these situations, the ball is either made to move faster or slower, or its direction of motion is changed. We often say that a force has been applied on a ball when it is kicked, pushed, thrown, or flicked. So the question here is, what is a force? Here we can see that a goalkeeper stops a ball, a hockey player flicks a ball, and a fielder stops a ball. All these actions are done with the help of force. So we may conclude that force is a push or a pull. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. Now we will do an activity to identify actions, various kind of actions as push or pull. We will describe a situation here and then categorize whether this action is pushing, pulling, picking, hitting, lifting, etc. And then we will group it as push or pull. So are you ready? Let us begin. The first situation is moving a book placed on a table. Yes, it is pushing, pulling as well as lifting. So it can be grouped as both push as well as pull. Then opening or shutting a door. It is again an activity considering pushing, pulling, lifting as well as lowering in it. And again it is both a push and pull. Then drawing a bucket of water from a well. It is lowering, lifting, pulling. And again both push and pull are here. Then a football player taking a penalty kick. In this activity, there is the process of lifting, kicking and hitting. And here it is just a push. No pull is there. The next activity is hitting a cricket ball by a batsman, in which hitting, lifting and flicking is observed, and it is a push, not a pull. Moving a loaded cart. It involves pulling and pushing. And yes, both kinds of actions are seen here, push as well as pull. Then opening a drawer. It involves the action pulling, and action can be grouped only as pulling. There is no push. So, each of the actions can be grouped as a pull or a push or both. We can conclude that to move an object, it has to be pushed or pulled. In science, a push or a pull on an object is called a force. Okay, it is a force. Just like you must have seen that a magnet attracts a piece of iron towards it. This attraction is also a pull. Similarly, we see repulsion between similar poles of two magnets, that is a push. Like South Pole and South Pole repels each other, North Pole and North Pole repels each other. So when does a force come into play? This is the striking question here. When does a force come into play? Dear learners, forces are due to an interaction. Like here in the picture, we can see a man standing behind a stationary car. Will the car move due to his presence? Obviously not. The man has to push the car to make it move. In the second part of the figure here, the car is being pushed by a man. it may begin to move in the direction of the applied force. So here the force is there. Now the next example of like first diagram, both the girls appear to push each other and the second one are trying to pull each other. So the girls in both situations shown here are applying force on each other. Who is pushing whom and who is pulling whom? Can you give its answer now? I hope no. Now in this figure, the cow and the man appear to pull each other. It means they are applying force on each other. But again, can you say who is pulling whom? No. So conclusion, at least two objects must interact for a force to come into play. Thus an interaction of one object with another object results in a force between the two objects. So interaction is essential for getting force into action. Interaction is a must. There are several directions of forces. Like two friends are pushing a heavy load. It is easier to move it. And they are pushing it in the same direction. But if the two friends are pushing heavy load in opposite directions, it is difficult. Why? Give reasons for this. When they are pushing it in the same direction, the forces applied on the object in the same direction add to one another. And if it is done in opposite directions, then the two forces acting in the opposite directions on an object, the net force will be the difference between the two forces. Is it okay with all of you? Just like in a game of tug of war, the rope may not move if the two teams pull at it with equal force. In this game, two teams pull at a rope in opposite directions. Members of both the teams try to pull the rope in their direction. The team that pulls harder, that is, applies a larger force, finally wins the game. You know it very well. So, the resultant force, the outcome, is seen on the side where greater force is applied. Dear students, here we can see the rope may not move if the two teams pull at it with equal force. There must be an unequal force to see an action. So we may conclude that a force may be larger or smaller than the other or equal to each other. The force is expressed by its magnitude with the direction in which a force acts. If the direction or the magnitude of the applied force changes, its effect also changes. It means that the net force on an object is zero if the two forces acting on it in opposite directions are equal. And in general, more than one force may be acting on an object. However, the effect on the object is due to the net force acting on it. Okay, so you have to be very clear whether the magnitude of the two forces is equal or unequal. If the magnitude is unequal, only then we will see an action. Thanks for watching, dear students.